Welcome back to this next part of our update video series. So this one is going to cover heat transfer, radiation, and interfaces. Interfaces fit naturally into this because lots of work has been done to deal with fluid-solid interfaces and allowing you to couple this type of problem together without doing enormous amounts of work to develop those imprints and coupling them, having the solver do the couplings for you and identifying the coupled regions. So without ado, let's move on. So the first thing I'd like to talk about is the problem you have when you've got two very different time scales, one for the fluid, which can be quite short, and one for the solid that can be relatively long. Imagine a combustion problem. You might have to run with milliseconds to capture the fluid dynamics, but your surroundings may take 15 minutes to heat up. If we run with that time step on both of them, it's going to take a very long time to model that heat up. So there are a number of different ways of approaching this, depending how strongly you want to keep the solutions coupled. So the easy way to understand this is skip to the next slide. So here, there's some explicit coupling model, it's called, where we have a solid time scale that's much longer than the fluid. And we step forward in time, but we're using different time steps for the two. And so we're developing the fluid flow, but we're also stepping faster the solid towards its final temperature. And then there's what's called loosely coupled CHT, where we're actually synchronizing in time, but as we move forward in time, we're using a much smaller step for the fluid time step as opposed to the solid. So the coupling across here is done based on some averaging, and we can move forward with this method where we're now always keeping the time consistent between them, but we're making use of very different time steps for the two processes. There's been a lot of validation work to do this, and this is now a release feature in the GUI. You can see some validation over here where it's been compared with fully coupled solutions. And just to let you know that if you want to use this, if you have a conformal mesh, then this is straight out of the box. If you've got non-conformal meshes, it's a beta feature. And so you'll just have to enable beta features. There have been improvements to the gradient calculations. Now, the problem occurs here is when you've got very significant gradients along an interface, so tangential to an interface. And the calculation of the gradient there can be very inaccurate. So there's a new set of schemes here that you can control from the TUI to actually disable some of these gradient terms, which actually can be unimportant but can cause very poor performance in the solver. So that's something to keep an eye out. If you're getting really bad convergence when you've got some complex solids there, go away and look at this as a possible cause. Been some mesh interface enhancements. So usability, we'll see later, there's been improvements to the GUI, there's been improvements to speed up, and then there's been some improvements to the robustness by cleaning up things like left-handed faces. So the GUI's been improved to have it both simpler, so we can see the interfaces, we can see the walls that we might want to make into interfaces, and it's just quicker and easier to use. There's been some improvements in the TUI to make it, if you want to do things in scripting, there's some extra options. There's the possibility of displaying where things intersect. So you can check whether there's good overlapping or not, and whether things have been projected well. So you can look at the interface on the fluid side, the interface on the solid side, and make sure they're good. It's a bit like the contact viewing in mechanical. And if you've got lots of these to make, then there's been a lot of speed up for some test cases here. Some robustness, there's a tool to remove left-handed, and there's a tool to improve gradient calculation. This is a very nice option. We know that when we've got a wall on the outside of a fluid domain, we can choose to model it in essentially 3 different ways. It can be just a basic wall, or we can give it a material and have 1D conduction through it, or we can give it a material property and put it in shell conduction so that we get conduction also tangentially through the shell. Now, if you want to be able to see what's going on, there's this new conduction manager, and it lists all the walls under their various categories, and you can open them up and do edits here, and particularly that's going to help you if you want to take a wall and change which category it's in, etc. It's much, much easier to do. You can also import data from a CSV file now. On radiation, there's been improved surface-to-surface clustering when you've got non-conformal interfaces. So that's going to improve the performance. Radiation modeling is now compatible with Euler-Euler multi-phase for both the gray and the non-gray discrete ordinates and the full Monte Carlo model. So for those of you needing radiation in multi-phase, this is a big step forward. And the solar calculator is now available to set up diffuse solar radiation with both the Monte Carlo and the discrete ordinate models. So that's all I've got to say on heat transfer at the moment. But I think you'll find that there are some really useful features there that you can make use of.